Hello, Andy. Hello, Mike.
Hello, Mike. Hello, Caio.
Hi, Andy. Hi, Caio.
Thank you for joining us. So, are you an iOS developer?
Among other things, yes.
For how long?
Uh, uh, a long time, 2009, maybe.
Wow, same time I
Okay.
started.
Yeah.
Good
Objective
times.
C, unfortunately. It's okay,
Yes.
but Swift is a
Manual
lot more
reference
fun.
counting.
Yeah, no, always automatic reference counting.
Yeah. Okay.
So, luckily.
Fantastic.
And were you doing development before iOS as well?
Yes, I mean, I'm actually an engineer, and so when doing hardware design, there's you have to do your own software as well. So back in the day, C assembly,
Wow.
all the way up to
Awesome.
Swift. Yeah.
All right. And how can we help you today?
I just started with a new team. I'm working as a consultant with a new team with a project that has had some sudden turnover. Uh, an earthquake happened, and some key developers have been swallowed up, and
Right.
now we're trying to rebuild the pieces. Uh, uh, the original architect of the project was a really experienced Java developer, and the project is well structured. There are tests. They use a structure called hexagonal architecture. So they're using ports and adapters, and the architecture is really nice. There are quite a few classes though, and being more experienced in Swift, it takes a little bit of time to adjust to these sort of dangling classes. But our main goal is we have an SDK that we're writing, and it's for iOS and Android.
Mhm.
And then we also have an app which uses this SDK. So we have an Android version of the app and an iOS version of the app. The initial version of this SDK is already complete. Of course, constantly features are being developed and improved. The design is, let's say, architectured so that the architecture is identical or as close as possible in iOS and Android. So I should say, like, the iOS app is written in Swift. The SDK for Android is written in Kotlin.
Mhm.
And I'm just wondering uh, maybe I have a two-part question. One is, if you were to take this project from scratch, how would you approach it? And then let's say you stepped into this project in the middle, and how would you take what you're given and continuously adjust and improve it to get to, let's say, an ideal goal or an ideal architecture?
Right. So, how to approach it if it was from scratch or from existing solution?
And do you get to the same path? Is the path to the same solution in the end?
Right. So, it feels like you're not happy with the current solution. Are you?
Well, it's quite good, but there's a lot of cognitive load. You have to learn. They've done a lot of custom things as opposed to going with more of a standard solution. For
Okay.
example, like sort of a large company, and there is like another team in another business unit doing a similar type of split, but they have chosen to architect them independently. So basically, they just have the same acceptance tests. So they both behave the same from the outside world, but inside, when you write the Kotlin or Swift, they're writing them independent. They don't have to have the same internal private classes or
Okay.
interfaces. This seems to be like the way I think you can go faster. But there's also some advantages to being class to class compatible. I would lean towards the way where the implementations are independent. Because I love the Swift language and you can take advantage of it. And Kotlin also, you can take advantage of what Kotlin has to offer.
Yeah, and if you try to make it one-to-one, you're going to have to make decisions that are not optimal for both sometimes, right?
Yeah, that's what I always say. If you want to design a car that you can sell in England and France, you can design it with the steering wheel right in the middle.
Right.
You know? And then you make a car that is no good for anyone. You know?
Exactly.
So, but there are some cases where this saves a lot of time, having one car.
Yes. There are benefits as well to sharing code between platforms even. Are you sharing any code between Swift and Kotlin, or is it like completely?
No, but like the architecture is similar. So architecture diagrams are shared.
Right.
But like actually, like they have different dependencies. So like the iOS and Android will use, like they'll use some of the hardware in the phones, and they use different interfaces there. So we have like the separate adapters that are injected, or so.
And the SDK is internal only, right? You don't share this with clients. Do you have any plans of sharing with other teams?
Yeah, the SDK is also a product. So the SDK will also be implemented by clients.
Okay, that's important then.
Yes.
SDK is shared with clients.
So they know about the external API of it, but they don't know about the internals.
Right.
Yes, that's the point I wanted to get. You would want, if you have a Swift SDK, the clients will interact with, at least the public interfaces should be 100% in Swift with standard definitions of what Swift developers would expect from a Swift framework. Right? You wouldn't expect stuff like get Boolean, things like that.
Right. There may be those type of things.
Yes. Now, it doesn't mean you need to have a completely separate SDKs because of that, because you can have a public interface written in Swift, but everything that's private behind the scenes can be a one-on-one match with both the Android, Kotlin, and the Swift one. Here, exactly the same as it is right now, right? So even though you have the solution right now that maybe you're not happy with because it doesn't share like a public interface they would expect, you can create that public interface and behind the scenes use that solution. So that's how you can start approaching it to deliver like an SDK to your clients that they will be able to easily understand and use. Like something that Swift developer would expect to see. And you only expose this public interface without exposing the underlying mechanism, which means that at some point you could even try to deploy a Kotlin version that works for multi-platform with the same public interface, right? You have much freedom. As long as this public interface, the clients only interact with this public interface they created, the underlying implementation doesn't matter that much, right? So you can either decide, you know what, everything's going to be in Kotlin, so we don't need to keep two frameworks. We're going to build Kotlin for Swift, but our clients will not interact with that. Either the clients that are internal in the company, the teams in the company, and the clients outside the company that will be shipping this SDK to. They will interact with the public interface they will design in Swift with standard Swift like conventions, right? And behind the scenes, maybe everything's a class, but the public interface will convert things to structs or enums, whatever makes sense. So this is a strategy you can start thinking about. That's what I would do if I'm dealing with an existing solution that doesn't have like good interfaces to interact with. I would create a in-between layer.
And then on your diagram, you would have the Kotlin public interface as well. And then I guess the documentation, you could be smart about writing the documentation and use the right method names as appropriate.
Yes. They can be separate products. They probably should be. They're different entry points, right? But behind the scenes, maybe they are using the same. But your clients don't know about that. Right?
Right.
It depends on the internal structure of your team. If you're happy to write it twice in both languages, that's fine. That works fine. But going from a existing solution, I would start working on a public interface using that existing solution behind the scenes, so I can keep delivering value to my clients, to the other teams in the company. And because of that, I have the freedom to later make changes to the implementation without breaking the client. As long as we keep the same public interface, you can make any change. You're free to change how this works. If it's written in Swift, in Kotlin, Objective-C, it doesn't matter, because the public facing interface is Swift, the interface you want. So write the interface you want, but behind the scenes you can use a framework that you're not happy with.
Okay, great. So then I should maybe concentrate a little bit more on that public interface. That's the important. That's maybe the most important
first
part.
step. Because when you have the good interface they want, then you can start seeing how to start writing or refactoring the existing code, or just keeping it one-on-one with Kotlin. Even if you don't like the design because it doesn't make much sense in Swift. If you think there is still the benefit of having this one-on-one match, as you say, for bug fixing, right? For any kind of, for teams even, like you can get a Kotlin developer to join the Swift team for a while and vice versa, right? Because they're sharing the same design.
One fun thing we do at the company is that we involve everybody in everything. So we do mob, and we're involved in both sides of the development.
Awesome.
Really get to increase your own personal value. It's pretty cool.
So that's my suggestion. Public interface, there is different for both languages, platforms. But behind the scenes, you can either share Kotlin, compile Kotlin for Swift, or have one-on-one, or you can completely rewrite it following that interface as well without breaking clients. You have freedom.
Okay, then part 2 is behind the scenes. What would you do? How would you approach it from scratch? Like,
it really depends on the project. I don't think there's a final solution. If it's a massive SDK and you have a lot of people writing the code twice, I'll probably give it a try on doing the Kotlin, that you build Kotlin for both platforms. I'll give it a try, maybe do a hackathon and see how hard it will be. If there are benefits, it's not that hard. Now we have one team creating the code once. When there's a bug fix, you fix bugs for both. And you just plug that with a Swift interface for your clients. So your clients shouldn't know about that. But what you need to pay attention as well, what's going to change, like what is the binary size? Will you have an effect in the binary size by using Kotlin there? Do you need to embed a bunch of libraries for that to work? Because if you're shipping an SDK to clients, those things start to matter, right?
Yeah.
Like imagine like you add Firebase to your app and suddenly you have 100 megabytes more.
Yes.
So this can be a problem. So will you have to add extra steps to your customers? Will you have any breaking like dependencies your clients need to care about? Right. So all of these you have to put in the decision-making list, like pros and cons.
And these ones are solved basically with the hackathon or doing little experiments.
Yeah.
To try and figure out.
Small experiments, like quick experiments, binary size, how hard would it be? Like, do I need to install a bunch of libraries? Do I need to make my clients install a bunch of libraries for the Kotlin thing to work? Are those libraries well maintained?
Yeah, and if if the team or the company doesn't provide the time to do a hackathon, like maybe you can do it in your own time just to experiment and like understand in a deeper level how the systems can interoperate between them, and that's a good thing. It's a good skill to have.
Yeah, it's also pretty fun. I would recommend. I tried just making some simple object and calling stuff from Swift. It's great. It feels like it's a Swift object. You can do extensions on it and everything, even though it's a Kotlin object. It's pretty cool. It uses Arc as well, not garbage collection for memory management. It's pretty cool. But more experiments. I didn't
Yeah.
check binary size, for
Performance,
example.
binary size, maybe some bugs. Things that work when you run the tests. Make sure that you run tests on both platforms, because some tests may pass on Kotlin Android processor, but there is a bug in the compiler from Kotlin to Swift or Kotlin to C that will actually result in different results, right? So you need to run the tests on both platforms, all tests. On all platforms you support. Even if you support iOS and macOS, when you run tests, the same library, SDKs, like we maintain some SDKs in both platforms. They pass on iOS, but they don't pass on macOS because there is a permission thing in the file system that is different, or you need an entitlement for accessing the network input output, like that. There are platform specific things that sometimes like it works on iOS 15.2 but doesn't work on 15.1. So platform and OS versions as well, language versions. And who's maintaining the Kotlin to Swift project? Is it something that will be maintained over time? All this. And if it's not maintained, do you have people in your team that could keep maintaining that going forward? What kind of resources do you have in your team to do this kind of support? So this comes down to skills in the team and resources.
That's a good point.
Here, depending on a third party compatibility that may not exist tomorrow, right? Who does Kotlin? Is it JetBrains? Maybe they go bankrupt. Maybe they're bought by someone else and they say, you know what, maybe Google buys them and say Kotlin is out. It can happen, right? So there is a risk here. Now, how big is that a risk for you? And what would be the worst case scenario and how would you manage that? All of these you need to bring to the table. And if you realize that, no, it's not worth the risk, we better write the native implementation in both Swift and Kotlin, then you have your answer there as well. But like you shouldn't be doing this check here for months.
Yeah.
Now tries to enter this quickly, like in a week time. Answer all these questions. Like, because if you're like Facebook and they create this React and they create all these solutions, like internally they have hundreds and hundreds of engineers creating tools to support that workflow for their teams. Maybe the company you're working for don't have those resources. So don't act like Facebook if you're not Facebook, right?
Yes.
Yeah, so productivity should be the goal, and like be careful of any paralysis here that might be caused by all this analysis and all the experiments.
Yeah, great point. Big picture. Yeah.
Absolutely. This should be
Yes.
the end goal. As developers, we tend to get a bit more dogmatic, into some technologies and ways of doing things, but in the eyes of the market, that doesn't matter. and the clients as well. They just want something to use so they can create products and ship to their clients and so on, right? So that's what's truly important.
Yes, they just want it to work. They don't care about architecture, any of this stuff.
Yes.
Classes, structs. Who cares? Thank you very much.
And if we're starting from scratch,
Yes.
right? I will do this research here, figure out if it makes sense to use a solution that is for both. If not, I'll write in Swift a public interface, and behind the scenes, I'll just probably go free between the two teams. Say, write it as long as it fulfill the requirements. And how do we know it fulfill the requirements? Shared acceptance tests. You will run exactly the same acceptance tests in both platforms, so they should pass. Now, can there be bugs even though the tests are passing? Yes. It's not bulletproof. There can be a bug in iOS and not in Android. But even if they're sharing one-on-one, there can still be those bugs there, right? Because one language is using maybe Arc, the other language is using garbage collector. And then there are differences. There might be a memory leak in one and not in the other. Or an object may be deallocated too early in one and not in the other, right? So there's still some bugs. So this is not bulletproof, but at least for the behavior should be the same. And both teams should follow test-driven development although you have the acceptance tests checking the behavior, you should have the developer tests you're developing to make sure that your implementation works.
Thank you. I think that's it. Really helped a lot. Awesome. Thank you, Mike, and thank you, Caio.
Yeah. Thank you. Thank you so much for joining us.
Appreciate it. Thanks.
Bye. Take care.
Bye. Take care.